Welcome to EDU World Space.
We know that the pressure change due to depth within a fluid is given by a change in pressure equaling the density of that fluid times the acceleration due to gravity times the change in depth, or delta H. And so for part A, we can say that here the change in height would be equaling the change in pressure divided by the density times g, the acceleration due to gravity. And so this would be, for part A, delta H would be equaling, this would be, for the denominator, 1.00 grams per cubic centimeter multiplied by 1 kilogram for every 1,000 grams multiplied by 10 to the 6th cubic centimeters for every cubic meter. This would be multiplied by 9.80 meters per second squared. And then for the numerator, we have 55 millimeters of mercury. And we know that we have 133 newtons per square meter for every millimeter of mercury. And so for part A, the change in height is giving us 0.75 meters. This would be our final answer for part A. For part B, we have delta H again equaling the change in pressure divided by the density times G. This is equaling now for the numerator 650. This would be millimeters, essentially, of H2O, or water. And then for every millimeter of H2O, we have 9.81 newtons per square meter for every millimeter of water. This would be divided by 1,000 kilograms per cubic meter, and then multiplied by G, 9.80 meters per second squared. So for part B, the change in height is equaling approximately 0.65 meters. This would be our final answer for part D. And then for part C, in order for the fluid to just barely enter the vein, the fluid pressure must be the same as the blood pressure. So again, delta H must be equaling the change in pressure divided by the density times G. This is going to be equaling now 78 millimeters of mercury. This would be multiplied by, again, 133 newtons per square meter for every millimeter of mercury. And then this would be divided by 1,000 kilograms per cubic meter multiplied by 9.80 meters per second squared. And so the change in height for part C is equaling 1.06 meters. This would be our final answer for part C and the end of the solution. Thank you for watching.